Today we will talk about the MSP430 microcontrollers for industrial applications, focusing on interfacing the MSP430 with industrial sensors. To give you a brief outline on today's presentation, we will first start with the sensor market, go through a generic block diagram of the industrial sensing loop, and then dig deeper into the TI solutions available for industrial applications. The MSP430 sensor market, what we currently see is that the industrial sensor sales is about 21% of the total sensor market worldwide. As technologies continue to advance, we will just continue to see growth in this area, especially for temperature, pressure, and flow. Although industrial applications require high accuracy, wide temperature range, and reduced system cost, ultra-low power in active and standby mode still remains a strong differentiator when it comes to picking MCUs. The MSP430 microcontrollers have been a leader in the ultra-low power microcontroller market for more than 2 decades. They help maintain design flexibility while delivering the best-in-class energy consumption. What you see on your screen is a basic block diagram showing the MCU interface with the sensor at the front end and completing the sensing feedback loop via a wired or wireless interface. Wireless sensor for monitoring doubled in the past year and will continue to grow, but is still a very small portion of the overall TAM. The most popular interfaces for industrial sensing are still the 4 to 20 milliamp current loop and the I/O link known as the USB or factory automation. We will talk about the I/O link in the latter slides too. This is a block diagram of the MSP430 i20XX family of industrial microcontrollers from Texas Instruments. It has some great integrated analog for industrial applications. It has up to 4 sigma delta converters that have high accuracy for precise measurements. Additionally, these SD24 converters support differential inputs, so outputs from the current sensor can be fed without the need for level shifting. Due to simultaneous sampling of SD24s, there is no delay between the current and voltage samples, thus eliminating the need for software compensation. The 20XX MCUs come with an internal DCO, eliminating the need for external crystal. The small packages help reduce overall area and cost. These MSP devices are functional across a wide range of temperature from -40 to 105. Check out more product and tool details at www.ti.com/MSP430. Let's see the TI designs that are available for industrial automation. But before that, let's take a step back and understand what TI designs actually are. As a part of our comprehensive ecosystem, TI engineers build application-specific solutions, which are reference designs to help developers jumpstart system design and improve speed time to market. These include comprehensive designs with schematic or block diagrams, BOMs, design files, and test reports. They are created by experts with deep system and product knowledge, spanning TI's portfolio of analog embedded processor and connectivity products. TI designs support a broad range of applications including industrial, automotive, consumer, medical, and many more. We will dig deeper into 3 TI designs for industrial sensing. These are shown on your screen. The first TI design that we will talk about is the RTD temperature transmitter for 2-wire 4 to 20 milliamp current loop systems. This comprehensive design provides a complete system that measures and processes temperature signal inputs from 2-wire, 3-wire, and 4-wire resistance temperature detectors and outputs a 4 to 20 milliamp current loop signal corresponding to the temperature processed from the RTD inputs. The reference design is intended for process measurement applications in factory automation, field transmitters, and building automation, due to its low power consumption. Let's talk about the device selection for this TI design. The first is the ADS1220, which is a low power, low noise 24-bit analog to digital converter for small signal sensors. Next is the DAC161S997, which is a 16-bit precision DAC for 4 to 20 milliamp loops and has a really small package. We will talk about the MSP430 in the next slide. Next is the TPS7A4901, which is an ultra-low noise, high PSRR, low dropout linear regulator. Coming to the MSP430 selection and interface, the MSP430 device records the raw ADC code from the ADS1220 device that corresponds to temperature reading, applies offset and gain calibration, converts the ADC code to a resistance value, performs linear interpolation to overcome the nonlinearity, and converts the given temperature from the lookup table to the DAC current after correcting DAC, gain, and offset correction. The processor selection for this TI design, the value line MSP430 device was selected for overall low-cost design. The 16K flash option was selected to meet interface and power requirements for the processor. Another option to consider for a RTD sensing solution would be the MSP430 i20XX that have 4 built-in 24-bit sigma delta converters. The next TI design that we will dig deeper into is the water meter using the SCAN interface. In battery-operated water meter, battery lifetime over several years is a key. One of the challenges is to continuously measure the water flow information while consuming as little energy as possible. The SCAN interface sensing peripheral integrated onto the ultra-low power MSP430 microcontroller is solving this problem. In water meter designs coupled to a LC rotation detector sensor, the SCAN interface is continuously detecting the rotation of the propeller while the rest of the microcontroller is sleeping in low power mode. The reference design demonstrates the usage of the SCAN interface to achieve ultra-low power consumption compared with the same detecting methodology using external circuit. By using the SCAN interface in MSP430 FW42X, most of the external components can be eliminated. Besides, measurement is done by the SCAN IF automatically. Once the SCAN IF is set up and enabled, the MCU will not be involved for measurement. The rotation is reflected as counter values can be set to low power mode for most of the time, unless an interrupt is set for specific actions such as reporting counter values. Since the MCU is freed up, there will be more MCU cycles available for other operations. If the MCU is set in low power mode, the system power consumption can be lowered significantly, as shown in the graph on your screen. The third TI design is the IO-Link sensor transmitter. Before we get into the IO-Link sensor transmitter design, let's understand what IO-Link is. As we saw in the block diagram earlier in the presentation, IO-Link is a wired interface in the sensing loop. It is called the USB of factory automation. It is a simple, cheap point-to-point protocol. The IO-Link masters can have multiple ports with one device connected on each port. The IO-Link devices can be sensors, RFID readers, valves, motors, and more. Let's get into details about the TI design, the RTD temperature plus the IO-Link transmitter. This TI design offers a rapid prototyping platform for IO-Link sensor transmitter. The system is programmed with a fully validated IO-Link stack, leveraging the fully validated IO-Link PHY. It comes by default with a switch emulating digital input, 2 LEDs for status indications, and potentiometer emulating an RTD. All this fitting in a 6mm wide PCB compatible with the industry standard M12 connector. This solution offers fast prototyping benefits to developers to improve speed to market. It serves as a full turnkey IO-Link evaluation and fast prototyping platform. The precision sensor interface enables easy evaluation with analog and digital input stimulus on board. Thanks to its modular design, different sections can be easily cut away to allow fast and simple interfacing of any analog or digital sensors. The layout is optimized to meet IEC, ESD, and EFT stress tests. Small 6mm board width addresses industry standard form factor requirements. The FRAM enables fast, secure sensor configuration updates and, of course, helps reduce overall power. For more product details on the MSP430 portfolio and industrial microcontrollers, visit us at www.ti.com/MSP430. TI designs are available at www.ti.com/TI design. Thank you.